Okay, so we're back now in our notes for rational functions, and we've completed steps 1 through 4. Now we're on step number 5, which is to find the horizontal or oblique asymptote if one exists. And in example A, we're carrying through, remember, the same problem each time. So 2x squared minus 8 divided by x squared minus x minus 6, right? We're still completing that same problem. Now we're on step number 5. So we're going to find the oblique or horizontal asymptote by dividing the denominator into the numerator and ignoring any remainders. So if I take this x minus 3 and I divide that into 2x minus 4. Okay, and I can use either long division or synthetic division. So I'm going to go ahead and start with the long division. I ask myself, how many times do I multiply x to get 2x? And that answer would be 2. Then I distribute. 2 times x is 2x. 2 times negative 3 is negative 6. Draw a line, change our sign, and 2x minus 2x is 0. Negative 4 minus a negative 6 is positive 2, and that's the remainder. Okay, we discard the remainder, and the quotient is the asymptote. So y equals 2 is my asymptote. Since that is a horizontal line, it's a horizontal asymptote. So horizontal asymptote. Okay. And another way that you could have done that was using synthetic division. Right? You don't have to do it both ways. It's just one or the other. So if I did synthetic division, instead of x minus 3 as my divisor, I would use positive 3. And then my coefficients, I have a 2 for my x and a negative 4 for the constant. We bring down the first value and then multiply. 2 times 3 is 6. Add those together. Negative 4 plus 6 is 2. That 2 at the end is the remainder. And then before the remainder is the constant. So remember, I discard the remainder. And so my constant, y equals 2, right? That would be my horizontal asymptote. Okay, so either way, right, it's either this or the one beside it. So you don't do both synthetic and long division, just one or the other. Okay, now in example B, right, we're carrying that over from our step 1, steps 2 through 4. Now we're on step 5, which is to find a horizontal or oblique slanted asymptote. And again, we're going to divide the denominator into the numerator and ignore any remainders. So my denominator is x plus 3. So if I'm doing long division, that is my divisor. Then my numerator is x squared plus x minus 12. And I'm going to ask myself, what do I multiply times x to get x squared? That would be x. Then I distribute. X times x is x squared. X times 3 is 3x. Draw a line, change the sign, and x squared minus x squared cancels. X minus a 3x is a negative 2x. Bring down the next value. Then we're going to multiply what times x to get negative 2x, and that would be a negative 2. Then distribute. Negative 2 times x is negative 2x. Negative 2 times 3 is a negative 6. Draw a line, change the sign. Negative 2 minus negative 2 is 0. That cancels. negative 12 minus negative 6 is negative 12 plus 6. So our remainder here is a negative 6. But remember, we discard the remainder, and then the quotient is the asymptote. Now this quotient is not a constant, it's a linear equation, y equals x minus 2. So that graphs a diagonal line, not a horizontal line. So this is a oblique asymptote. Oblique means slant. So y equals x minus 2 is the equation of the oblique asymptote. Okay, since that divisor is linear, right, I could have done synthetic division instead. So again, it's either long division or synthetic division. So if I had chosen synthetic division, instead of x plus 3 as my divisor, I would use a negative 3. Then the coefficients, I have 1x squared, 1x, and negative 12 is the constant. We bring down the first term and multiply. 1 times negative 3 is negative 3. Add 1 plus negative 3 is negative 2. Multiply negative 2 times negative 3 is 6. Add negative 12 plus 6 is negative 6. And that negative 6 is the remainder, then the constant, and then the x. We discard the remainder, and then this would be my oblique asymptote. Okay. Now you'll notice up in the corner here an acronym: Bobo Botan eats DC. Okay, Bobo Botan eats DC. This is a popular acronym for having to not do division every time. You can always do either long division or synthetic division, and you're going to find the horizontal or oblique asymptote. However, this acronym is a shortcut, so BOBO means bigger on bottom 0. Bigger on bottom 0. So if the degree of your numerator is bigger, or I'm sorry, degree of your denominator, bigger on bottom. So degree of denominator is bigger than the degree of the numerator, then y equals 0 is your asymptote. Okay, Botan is bigger on top none. So bigger on top none means there is no horizontal asymptote if your numerator is a bigger degree than your denominator. Instead, there will be an oblique asymptote. And so if you look at this example B, right, we have x squared in the numerator and x in the denominator, so degree is bigger on top. So we had no horizontal asymptote, instead we had oblique. Then eats DC means exponents are the same, divide coefficients. So if you notice in this one, example A, the exponent in the numerator is the same as the denominator, and my coefficients are 2 and 1. So if I divide those coefficients 2 and 1, I get y equals 2 as my horizontal asymptote. So again, Bobo, bigger on bottom 0. Botan, bigger on top none for horizontal. Instead, you do division to find the oblique. And then eats DC is exponents are the same, divide coefficients. Okay, so that's just an acronym for shortcuts if you want to use it. Otherwise, you can always do long division or synthetic division if it's a linear divisor to find your horizontal or oblique asymptote. Just remember to ignore that remainder.